This is the last lesson that we'll deal with in Chapter 1 of the Elementary Statistics course. This is called Beyond the Basics. We're talking about beyond the basics of collecting data. We'll start off with the fact that we have three types of observational studies. The first one is the one that's done in the present. We call it a cross-sectional study. That's where we have data observed, measured, and collected all at one point in time in the present. A retrospective study, sometimes called a case control study, we take data from the past, including examination of records, interviews, anything that would pertain to the study. And the last, if we visited the present and the past, talk about the future, a prospective study, sometimes called a cohort study, because you're dealing with cohorts, you're dealing with groups of people that you want to watch over a period of time in the future. The data is collected from the future, and they share common factors, these cohorts or groups. The best prospective study of late is the one, anything to deal with smoking, because we don't know enough about it. Any other types of medical studies are typically prospective studies. Your design of experiments is very important if you're going to do some sort of experimentation. Randomization, obvious. When subjects are assigned to a group randomly. Replication is the repetition of an experiment on more than one subject. That is clearly necessary for any good study that any medical field wants to do. They have to do it over and over and over again. You cannot just do it on one person and expect it to be gospel. Blinding is when the subject has no knowledge of whether or not they have received treatment or the placebo effect. And the placebo effect is when an untreated subject reports improvement in any type of symptoms that they've had. They could be real or they could be imagined, i.e. being a hypochondriac. A double-blind experiment is when there's blinding at two levels. The most common being the subjects don't know what they're getting and the doctors don't know what the subject is getting as well. That, in my personal opinion, is the way to do most experiments, because then you don't have prejudgment on anything that you are doing. Experiments always have variable factors that have to be included. We've talked several times about different variable factors that could be in any type of experiment. In class, we use the example of looking at the spin on golf balls on the golf course. And the things you have to take into account, of course, would be wind and the stent meter of the greens, how difficult the greens are. Also the cut of the greens. Confounding occurs when someone can't distinguish the effects of the factors. If we can't distinguish the differences on the spin of the golf ball because of the fact that we just can't tell if the wind is bothering it or not, we have confounding occur. We do not want that happening. Planning is absolutely critical anytime you do an experiment, because you want to avoid confounding at all possibilities. There are ways to avoid confounding. First of all, any experiment should have complete randomization. There is such a thing called randomized block design. A block is just a group of subjects that are similar, and the blocks sometimes can affect the outcome of the experiment. So what you want to do is form blocks as you can with as many similar characteristics. You might want to do more than just one type of characteristic, and make sure that you are randomly assigning treatments within the blocks. There's the rigorous controlled design that has careful assignment of subjects to different treatment groups. That basically assures that all treatment will be given similarly. The only problem that I would see with rigorous control is that you can tend to be biased with that because you're controlling who's getting what. Match pair design, you want to find two people that are as similar as possible. One person's going to get the treatment, the other person's going to get the placebo, and hopefully your results come very well with that. Errors that can occur, a sampling error is the difference between the sample result and what the true population gets. A non-sampling result would be a ding-dong move. You have sample data that you collect, you record, and you analyze incorrectly. There's some sort of flaw in your analyzation. The homework in this section is textbook page 36, numbers 27 to 31. It's very critical that you put some thought into these questions. You don't really want to just, it's not really cut and dry. It's really about what you think and what you think could go wrong in the particular questions.